comes these people, they are going to study these patterns, because we have said before that patterns are everywhere. Now people just need to learn to notice them. That's why in mathematics we say it's a study of patterns. Okay, so it says here that is the reason why those who use patterns, uh, why those people use patterns to analyze and solve problems, okay, uh, often find success compared to those who cannot. Okay, and we have different types of patterns. Now we have patterns in nature, arts, architecture, and even the human behavior. Okay, so this afternoon, our objective is to find or to study the different types of patterns that we see. Okay, and maybe some of you have prepared now some uses or examples of these different types of patterns as seen in nature, art, and architecture. Okay, so I'm going to make co-host, okay, the first group who will be presenting. Okay, so who is the first presenter?
Walang sound, ma'am.
Walang sound in.
At a glance. Quoted from Mr. Blaise Pascal. Hi there, Una Cinco, and to our stunning professor, Ma'am Bangas. Our group will be discussing one of the most known patterns today, symmetry. Familiar? Have you heard it before? Well then, we'll be discussing it today. Taisho seto wa nan desu ka? What is symmetry? According to Oxford Language, it is a quality of being made up of exactly similar parts. In short, balanced proportion. Here, I have an isosceles triangle. These two parts divided by a vertical line, called axis or line of symmetry, is symmetrical because when folded along the line, it matched exactly. Next up, the three types of symmetry. Take it away, Mom Shriza.
Thank you, Mom Shmaylene. When you look closer at the ordinary, your perspective will change as you acknowledge the uniqueness that they possess. Bilateral symmetry is the simplest kind of symmetry and the one that is mostly observed in our surroundings. If an object would be divided into halves, both sides would look just like the same, or in other words, symmetrical. Some of the many examples are the Petronas Tower in Malaysia and the Louvre Museum in Paris, France in terms of architecture. The blue morpho butterfly, and yes, our face is symmetrical. Lastly, and without doubt, it exists in art, just like the logo of the Batman and photography as well. Isn't there balance and harmony soothing? Well, that's bilateral symmetry for you. Mom's Francesca, the floor is yours.
Radial symmetry. This is a kind of symmetry that radiates from a center point repeatedly. The examples of radial symmetry in architecture are the famous Lotus Temple, which is located in Delhi, India, and the famous rose windows of Notre Dame Cathedral at Paris, France. Another example of radial symmetry is the mandala, which is the human-made symmetry. Lastly are the examples of radial symmetry based in nature. And these are the growth point of a tree, a spider web, and the petals from a flower. That's all for the radial symmetry. Boss James, take it away.
Okay, so another type of symmetry is the five-fold rotational symmetry. Though uncommon, it is also found and applied in nature, art, and architecture. It's a type of symmetry that resembles the shape of a pentagon and seems to have 5 points like a drawing of a star. According to a survey made, when a number of respondents were shown a triangle, a square, and a pentagon and asked what is less symmetrical, majority of them chose pentagon since it looks mysterious in the concept of symmetry. And due to our subconscious sense of balance, we tend to overlook such patterns. Symmetry may come in different forms, but with deeper observation, they become emphasized and obvious. This type of symmetry can be seen in molecule formations, in flowers, sea urchins, and in iconographies and other more. So next po ay si Trixie Andres.
A lot of people may not notice, but symmetry is all around us. It adds beauty in the world that we live in today. Symmetry allows us to imagine, open our minds, and envision our world as balanced and equal, despite of the unsteady and off-balance society that we have. Radial symmetry helps us to understand how the world functions no matter what angle we see. It just looks the same as we experience similar things. It is in the human hands to find and look deeper on the underlying patterns of the world.
Or reflection symmetry. They also presented rotational symmetry, or what they call the point symmetry, and five-fold symmetry, and other types of symmetry. We're going to discuss that later on when the other groups are going to present. Actually, say symmetry, ito na yung pinaka, when I say patterns, what you usually see, what usually comes to our mind is what we call symmetry. Okay, before we continue with the next group, okay, we can say here, we say tidiness is a virtue. Symmetry is often a constituent of beauty. Diba? When you say basis of yung pinaka beautiful, who is beautiful? Okay, of course, beauty is in the eye of the beholder. Pero when you speak of beauty, especially if we discuss what we call the golden ratio, one requirement for something to be beautiful is what we call symmetry. Okay, so thank you, first group. Okay, so
patterns in nature are visible regular forms found in the natural world. These patterns are identified mathematically. One of these patterns is called tessellations. Where does the word tessellation came from? The word tessera in Latin means a small stone cube. They were used to make up tessellata, the mosaic pictures forming floors and tilings in Roman buildings. A tessellation is also called tilings and is created when a shape is repeated over and over again, covering a plane without any gaps or overlaps. In creating tessellations, one can use mixed shapes to create tessellating patterns, such as triangles and hexagons or triangles and squares. The only rule is that the sides must all sit flush against one another, leaving no gaps or empty spaces at all.
To know more about it, here's the history of tessellation. So, the tessellation can be traced back even in the ancient times. In the BC era, the Sumerians, Egyptians, and Persians built their homes and temples using clay tiles with geometric patterns. In 1619, one of the first documented studies about tessellations was done by Johannes Kepler, in which he wrote about the two of several types of it, the regular and semi-regular tessellation. In 1891, the Russian crystallographer Fedorov proved that every tiling of the plane is constructed in accordance to one of 17 different groups of isometries. His work marked the unofficial mathematical study of tessellations. In the year 1972, Dutch graphic artist named Maurits Cornelis Escher, also referred to as the father of modern tessellations, for his artwork enjoyed by millions of people all over the world. His concepts about tessellation are widely used and adapted in the modern mathematics world. Here are the types of tessellation. The first one, regular tessellation. These are tile patterns made using only one kind of polygon. It has three types: triangles, squares, and hexagons. Next, semi-regular tessellation. It is formed when two or three types of polygon are arranged the same at every vertex or corner. Third, demi-regular tessellation, also called as polymorph tessellation. It is made by combining two or three polygons arrangement and always containing two vertices. However, it is not recognized by most mathematicians.
The fourth type of tessellation is called non-regular tessellation. It is a group of polygons that have the sum of all interior angles equaling to 360 degrees. The fifth type is called three-dimensional tessellations. From the word itself, it uses three-dimensional forms of shapes. And the last one is called non-periodic tessellations. It is a tessellation or tiling that does not have a repetitious pattern. Tessellation can be seen in nature, architecture, and arts. Here are some examples of tessellations in nature. The first one is cracked mud. Next is the skin of snakes, aloe vera, leaves, pineapple fruit, flower, sunflower spirals, and honeycomb.
Here are some of the examples of application of tessellation in architecture. And lastly, here are the examples of tessellation in art.
That's all for our presentation po. Thank you po.
Shape styles with no overlaps or gaps. So for example, in a quiz, what type of pattern, blah 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 blah, pag nakita nyo no overlaps and no gaps, we have now what we call tessellations. Okay, and we have certain conditions for geometric shapes to what we call this tessellate. Hindi lahat pwedeng circle ba magte-tessellate sa, for example, triangle. No, di ba? Okay, so you have to check what we call the measurement. No, it should be equal to 360 degrees. Okay, so that's another type of tessellation. Very good. Group 2, you have given us samples, no, and the different types. Okay, so congratulations. Next, who's next here now?
Group 3 po, ma'am.
Group 3, okay, we have fractals. Okay, so fractals is, I think, one of...
Okay na po, ma'am.
Okay, so thank you. So when you say fractal, it says it still have what you call symmetry. As you can see, if you were trying to check their what you call arts, no, and architecture.
Nakikita na po.
Yep. Okay na. Yan. Good.
Good day. I am Arian Claire A. Oronat. Today, we will be discussing about Frieze pattern. Let's start the discussion in defining Frieze pattern and a little background about this. Frieze pattern, also called as border pattern and infinite strip patterns. This is a design which its basic motif is repetitive, or it repeats over and over in one direction. It can be straight horizontally or vertically. Such pattern usually find in our nature, in decorative arts, and in architecture.
Thank you, Ms. Aronan. And now, let's go back to our topic, the 7 types of Frieze patterns. The names of each pattern were coined by a mathematician named John B. Conway. For the first group, it is known as F1, which contains only one translation, symmetries. According to Conway, F1 is also called a hop, as it resembles a footprint of hopping, heading in one direction with right feet. Next, the second Frieze group, or F2. It contains translation and glide reflection symmetries. It is also known as the step, similar to stepping or walking with both feet, heading in one direction. As for the third Frieze group, F3, or known as Seidel, it contains a translation and vertical reflection symmetries. It is like a mirror or sideway patterns. Next and fourth pattern, the F4, it contains translation and rotation by a half-turn symmetries. F4 is known as the spinning hop. That is because it is like a hop of the F1, moving in one direction and then turning to the opposite side. For further discussion of the patterns, we should all now listen to Mr. Mativo.
Good day, everyone. I'm RJ Matibo and I will continue the report of Miss Tangi about the different types of freeze patterns. Fifth in the list was spinning sidle. As you can see, the second pattern is the reflection of the first pattern, and then it continues to create a stunning artwork. The sixth pattern is what we call jump, which contains a horizontal reflection symmetries. Lastly, on the freeze pattern was a combination of all symmetries. It was called a spinning jump. Let us all hear Miss Sophia Manson's voice to explain more about examples and other stuffs.
Thank you, Mr. Mativo. Alrighty, now that we already have an idea on what freeze pattern is and being able to distinguish its types, it's time to know where do we see these patterns in the real world. And by that, I'll be giving you examples of these patterns, which can be seen in nature, in arts, and in architecture. In nature, there are a lot of freeze patterns that can be seen, such as in honeycomb, leaf, arrangement of phospholipids, and southern copperhead snake. As you can see, it is demonstrated there on how they become a hop pattern, a step pattern, a spinning hop, and a spinning sidle. Next, in arts, the first example is Andrew Glasner's hand-drawn pattern, and it is an example of a sidle pattern. The next example is Nuestra Senora mosaic, which illustrates the spinning sidle pattern. Next, the Mezquita ceiling, which is an example of a jump pattern showing a horizontal reflection. Lastly, the back of a bench in Seville, Spain, showing a spinning jump pattern. Now, coming into architecture, we have Maclay's cast iron product, which is an example of a hop pattern. At Tepe Madrasa Mosque, which is an example of a sidle pattern. An iron fence showing a spinning jump pattern. And last but not the least, the timber frame house in Germany, which shows a spinning hop pattern. Thank you for listening.
Good, very good presentation material, like it. Okay, so the others take note. Okay, different types of patterns wherein you can use as a basis when you're going to do your e-portfolio, when you collect photos of the different types of patterns. Okay, so we move on. Thank you very much, group 4, to group number 5. Is it wallpaper or rosette patterns?
Rosette patterns po, ma'am.
Okay, Christine.
Good day, everyone. We are Group 5 and our topic is about rosette patterns.
Ayan, we'll start sa definition ng rosette patterns. Rosette patterns consist of taking a motif or an element and rotating and or reflecting that element. Take note na sa definition na to, sinasabi na para sa rosette patterns required yung rotational symmetry. However, pwede din siyang mag-exist with or without reflection symmetry. In other words, ang isang figure or ang isang shape, hindi siya ma-recognize as rosette pattern unless may rotational symmetry na pinapakita sa kanya. A rosette pattern describes the possible symmetries of a flower or a pinwheel. So, ayan, para madali nating ma-distinguish or ma-recognize ang rosette pattern, pag sinabing rosette, very similar siya sa pattern ng flowers. Kasi yung gitna ng flower, yun yung magsisilbing center or common point. And yung petals around it naman, yung magde-define ng repetition aspects ng rosette patterns.
So we have two types of rosette patterns. Number one is cyclic, admits only rotational symmetries. When we say rotational, it is circular movement or directions. When I say symmetries, it refers to having same images of an element or pattern. So when we put rotational and symmetries together, rotational symmetry, it means that the repetition of an element which makes up a pattern is in circular rotational direction. So proceed to dihedral. Dihedral admits both rotational symmetries and bilateral symmetries. So bilateral, bi means two, lateral means sides. From there we could derive that both sides have the same mirror images of one another. So kunyari kapag trinace mo yung image na may pattern, kunyari pag vertical, in a vertical direction or maybe horizontal or diagonal, both sides have same splitting image of one another. So, sige, pareha sila ng details.
For better understanding, these are rosette patterns manifested in nature. Yung nasa right side ay aloe vera plant, yung nasa left naman ay tinatawag na endive. Yung aloe vera ay example ng cyclic rosette pattern since rotational symmetry lang yung meron siya. Although may common point tapos more than one yung axis of symmetry niya. Di siya symmetric kung susubukan nating i-mirror. Yung second example naman ay dihedral rosette pattern. As you can see, may focal point at pag susubukan natin siyang i-cut along different axes, magme-meet pa rin sila sa point na yun while being symmetric. Tapos pag nitry nating i-mirror, yung left and right side niya ay talagang mirror images ng isa't isa.
These are the two examples of rosette patterns in architecture. The first picture represents cyclic pattern. It features rotational symmetries. And the next picture is a dihedral pattern, which admits both rotational symmetries and bilateral symmetries.
Ito naman yung example ng rosette patterns in arts. As usual, yung sa left yung dihedral. Pag sinabing dihedral, di ba may rotational symmetry tsaka reflection symmetry. Kasi dito actually may 5 lines of symmetry. Tapos pag subukan nating i-fold in half, exact mirror images pa din sila. Sa right side naman ay cyclic rosette pattern. Kasi rotational symmetry lang talaga yung pinapakita dito. And it doesn't make sense kapag sinubukan nating i-connect siya along different areas.
So this is the last slide of our group report. These are the other examples of rosette patterns. At least try to identify whether each picture is cyclic or dihedral. That's all for group 5. I hope you understood the discussion. Thank you for listening.
We can see it in nature but more on arts and architecture. Okay, so with frieze pattern. Okay, we move on to the wallpaper patterns. Actually,
wallpaper pattern is a plain figure which has more than one direction of translation symmetry.
For wallpaper patterns, the multiple translation direction force the pattern to cover the entire infinite plane. A finite portion of a wallpaper pattern is enough to establish the translation symmetry, which is used to extend to the entire plane.
According to Nakon, 2016, in order for a plane figure to be considered a wallpaper pattern, it must have at least the basic unit, one copy by translation, and a copy of these two by translation in the second direction. There must be at least 2 rows, each one of at least 2 units long.
Up to date, there are 17 groups of wallpaper patterns: P1, P2, PM, PG, CM, PMM, PMG, PGG, CMM, P4, P4M, P4G, P3, P31M, P3M1, and P6.
Each wallpaper pattern is based on a pair of translation in different directions. The translations are applied multiple times to give a repeating image. This is defined as a regular grid of points called lattice.
The image inside a wallpaper, if rotated and reflected, produces the final image. It is called the fundamental domain.
Mathematics is beautiful, so as wallpaper patterns. Is a quote from Joseph Fourier. Mathematics compares the most diverse phenomena and discovers the secret analogies that unite them. Math let us see the world in a logical and rational way.
We call this 7, no? And then we have this wallpaper patterns. I'm not asking you to memorize it, okay? But at least you know that there are 17 groups, okay? And you know, for example, to determine whether that is a frieze pattern, a rosette pattern, or wallpaper pattern, okay? So thank you very much. That was group number 6. Group number 6 na yun, no? Okay, let's have now, okay, one of the, what you call this, not really special pattern, okay? The famous types of patterns. Okay, we have the Fibonacci sequence. Okay, ready na?
Kita na po?
Yes, we can see it now.
Good day, everyone. Our report is about the Fibonacci sequence. Here in the figure, we can see the Fibonacci spiral. The Fibonacci sequence has been introduced to us as early as our elementary days. The Fibonacci sequence is a series of numbers where a number is the addition of the last two numbers starting with 0 and 1. The Fibonacci sequence can go as follows: 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 35, so on and so forth. The Fibonacci numbers were first discovered by a man, Leonardo Pisano, also known as Fibonacci. The Fibonacci sequence was a product of the experiment that he made about rabbits. He observed that every male and female rabbit that is put in a cage subsequently reproduce another female and male rabbit, so on and so forth. And that's how the short history of Fibonacci started. The Fibonacci sequence can also be applied in different ways, such as patterns. We can apply the Fibonacci sequence to the patterns that we can observe in nature, art, and architecture. First up, nature. The flower pattern. The flower pattern is the pattern of seeds within a sunflower that follows the Fibonacci sequence. As we can see in the figure, the Fibonacci sequence has been applied in the overall construction of the middle part of the sunflower. As we can see, it started from the middle part and it goes on following the Fibonacci sequence. And here we can see the Fibonacci spiral. The pattern is inspired the Fibonacci sequence, of course. As we can see, the Fibonacci spiral can be perfectly aligned in the shell of the ears of the human body. So we can therefore conclude that the Fibonacci sequence can also be applied and can also be seen in the human anatomy. as well as in the overall measurement of the human body. Here we can see that the Fibonacci in relationship with the human head and the Fibonacci sequence in relation with the human body. The Fibonacci sequence can also be applied in art. Here in the art piece of Robert Graham's named Tango Final British Championship, Blackpool, way back in 1969, we can see that the image of the entire composition is perfectly outlined by two Fibonacci spirals, which is the upper one and the one at the bottom, which trace the line of the spotlight dance floor, the skirts in the arm of the dancer, and even the curve of the central lady's neck. The place of the focus perfectly on the foremost couples. As well as in the art piece made by David Oyens, Young Women Reading in the Studio way back in 1901. As you can see the image, it takes in the curve of head and shoulders with the line extending along her forearm, sweeping out to the encompasses of the chair and the vertical line of the window. The angle of the easels is in the background. As we can see, the Fibonacci spiral is also applied in this art piece. The Fibonacci spiral can also be seen in architecture that is dated way back before internet access. Then first up, the Great Pyramid of Egypt. As we can see, the Fibonacci spiral has been applied to the overall composition and can be seen in the overall structure of the Great Pyramid. This is twice the vertical height and the value of the overall structure. As we can see, two spirals, Fibonacci spirals up to 4 can be seen here. We can refer in the first figure. Next. The Fibonacci spiral can also be seen in the Parthenon that is located in Greece. As we can see, the Fibonacci spiral perfectly aligns to the structure of the Parthenon. So as we can see, even before the Fibonacci spiral has been observed and can be used in different architecture, art, and nature. Next. And that's all. This is the end of our report. I hope you all learned a thing or two about our report. And thank you for listening. Have a blessed day.
Thank you very much. No, I really like the presentation. You've explained how it becomes what we call the Fibonacci, an example of what we call the Fibonacci sequence. No, so connected to what we call the Fibonacci sequence, we have the golden ratio. So notice they've already introduced what we call the spiral. We call it the golden spiral, the golden rectangle. Okay, or what we call now we have what we call the golden ratio. Next, in the last group.
So good afternoon, everyone, and especially to you, ma'am. So now we are going to discuss about the golden ratio. Next. So mathematics plays a principal role in our daily lives. As we can see, it can incorporate with our daily computations, application, and inspiration. It's also used in various ways, even if we do not realize it. The roof above our heads, example, the roof above our heads, the measurements of our shelters, the measurement of the ingredients that we use for our food, etc., that are attained with precise calculation through mathematics. So these things are has a connection with mathematics. So we cannot, though we cannot see math, it's a part of our journey in our daily lives. Next. So this is the golden ratio. Golden ratio, also called as phi or phi golden mean or golden section express is expressed as the 1 plus square root of 5 over 2 is also this is the the symbol for phi is the classical shape based on phi is the golden rectangle where phi appears alongside with the perfect unit square. So nakikita sa sa gilid na yung example ng golden ratio. Next. So the golden rectangle. So this is how we construct a golden rectangle. So first we will have a square. We will create a square with one with a measurement of 1 each